Sweet. Okay, so we're going to be working on that little paper that y'all picked up, and it's just like a further look into all the trig functions like sine, cosine, tangent, and then the ratios that they equal, because just like y'all know, like y'all have gone over SOHCAHTOA, of like the sine of theta equals the ratio of opposite over hypotenuse, and we're just going to go into that. But we're going to go further into like the inverse trig functions so that we can solve for the angles that y'all have been doing. Okay, and so so we're going to go into it with this first one of this triangle that we already have up here. And like the first thing that I always like to do whenever I look at these triangles is just to label it. And so that way when you look at it, like a lot of times like my brain would get stressed when I would look at exams and I would just get overwhelmed with all the information. And so like it's easier to just label what you have, and so that way you can see what you have and then go from there after you take a deep breath. And so on our triangle, we obviously see that we have theta right here in the bottom corner. And so the opposite side from that is this 12 over here, and so we have the opposite, and then our adjacent is this side down here on the bottom. And then the hypotenuse is this long side with the 15.7. And so we'll set up the function that we're going to use with this one. And so with like SOHCAHTOA, we know that sine is the opposite over the hypotenuse. And so we have the sine of theta equals the opposite over the hypotenuse. And so the inverse function, the whole point of like having inverse trig functions is so that you can find the angle. And so it literally just flips the theta and the ratio over there. So we'll have the inverse sine of the opposite over the hypotenuse equals theta. So everybody get that? Literally, it just moves it. It's the exact same ratio. You don't flip it. You literally just move the theta and the ratio and just put it inside of the sine function. And so that way you can solve for theta. And so we have the inverse sine of 12 is the opposite, so we have 12 over 15.7 equals theta. And so let's plug that into our calculators. And so we go to the trig button, and so we have the inverse sine of 12, and then over is basically just divided, we know that. And then it's 15.7, and we'll close parentheses. And see, it puts us in a fraction for us. And so that's 49.8. Okay. And then in the problem, it says to round to the nearest degree, though. So we got 49.8, but then when we round, it's 50 degrees equals theta. Does that make sense? Does everybody get it? Awesome. Let's go to the next one. Okay. So how am I going to label this? So we know that theta's right here. Can somebody tell me how to label the different sides of this triangle? Yeah. Yeah? Yeah, the hypotenuse. Awesome. Thank you. And what trig function am I going to use? We're just going to set it up right now. So don't do an inverse yet. Yeah. No, you're right. Because the tangent of theta equals what? Yeah. And so it's going to be the 11 over 7. And so then we're going to do the inverse tangent, which is just going to bring it inside of the 11 over 7. That's going to equal theta. And then we'll plug this in our calculator. 11 over 7. And we'll close it. And that's going to give us 57.5. And then when we round, it'll give us 58 degrees. Equals theta. That makes sense. It's basically the same, just we're using tangent this time. Okay. Okay, and so this next question is just a slightly different. It says the chairlift at a ski resort rises at an angle of 20.75 degrees while traveling up the side of a mountain and attains a vertical height of 1,200 feet when it reaches the top. How far does the chairlift travel up the side of the mountain? Can somebody come and just like set it up for me? You don't have to solve it yet. I just want you to like set up the trig function. I have a random number generator. Okay. Who's number 32? Do we have a 32? We don't have a 32. 26 is... How do you say your name? Brunda? Okay, cool. Can you come set it up for me? Yeah, we're solving for D, which is a hypotenuse. So you can label the triangle first, if that'll make you feel better. Or... You don't have to, because you're already given this angle on the bottom, and so any trig function will get you any side that you're looking for. And then we're solving for D, which is the hypotenuse. Yeah. Mm-hmm. Yeah. Yeah. That's perfect. Yeah, so obviously as we can see by Brunda, so we're given this angle right here, this 20.75, and from that we have the opposite, which is this 1,200 feet, and then we're trying to find the hypotenuse, which is D. And so it's set up by this right here. And so we'll just do like a little bit of algebra to get the D by itself so we can solve it. And so we'll multiply the D. So that gives us D sine 20.75 equals 1,200. And then divide the sine equals 1,200. It's right under your chair. Thank you. Rhett and Aiden. Rhett. Okay, so we have 1,200 over sine of 20.75. And so D equals, we'll plug it in our calculator one more time. Okay, so that's 1,200 over trig, and that's sine of what? So we have 3,383 feet. 383 feet. Okay, does that make sense? Yes. Great. Oh, wow, I did. That was a lot of numbers. Okay. I'm just going to pull up again. Nope. That's not what I want. Here. Of course. There we go. 3387. Cool. Thank you. Okay. Does that make sense to everybody? Okay. So we'll go into this one, and it says a sightseer on vacation looks down into a deep canyon using binoculars. The angles of depression to the far bank and near bank of the river are below are 61 and 63 degrees, respectively. If the canyon is 1,250 feet deep, how wide is the river? And I'm just going to give y'all like a minute or two so you can draw the diagram. Just so you can like visualize it better. Okay, is there anybody that thinks that they have it? You got it? All right. You gonna come up and draw it for me? Nice. Um, the only thing that is different is that it says the angle of depression, right? And so the angle of depression goes down. Thank you. Okay. And forward. Who is forward? Oh, yes, you're outside. Okay. And so it's like on a canyon, let's just say that you're standing like right here. So your angle, your like reference is going to be from right there. And so this is going to be your 61 because it's going to be your angle of depression that goes down. And then the 63 is going to be this bigger one as it goes down. And so Juan was right whenever he had these angles down here because like y'all learned yesterday, the transverse angles, they are just a little, they're just flipped. And so this is going to be your 61 because this is your triangle right here and that's going to be your 63. Does that make sense? Because it's the opposite interior angle. Okay, cool. And so just to solve this, like y'all can see from here, like you have two different triangles. And so you can like draw them to, you can draw it to like separate it. And so we have one triangle, two triangle. And so let's label it. And so we said that there's the 63 right here, and then we have 61 right here, and then here's our right angle. And then the height of the canyon, as we've said, is 1250. And we're solving for, so we have these two different lengths that we're trying to find because we have these two different triangles. And so we'll say that the shorter length is x and the longer one is y. And so the shorter triangle is going to be 63 and the longer one's going to be and the y. Okay. And so can somebody come and set up these two different trig functions for me? Okay. Who's 22? is Kimberly. You just have to set it up to solve for it. You don't have to solve it yet. We're solving for the x and the y. Yeah, right? Because we don't have the hypotenuse. Just anywhere. Wherever space. Because it's the tangent of theta. Yeah. Yeah, you just missed the equal sign in between tangent 63. Yeah. Because it's the opposite over adjacent. And it's the exact same for the other one. If you want to write it down for me. Yeah. Because we're solving for the same side, we have the same information, it's just different with 61. Yeah. Awesome. Thank you.
Could she have used another trig function besides tangent? Tangent. Okay, good.
Nice. Great. Okay. And then so again, we'll just do the algebra to solve for the x on here. So we have 1250 over tangent of 63. And then for y, we have 1250 of tangent over tangent of 61. And then, can somebody plug that in for me? What does x equal? Oh, no, you're fine. You're okay. What was it? 600 what? I'm sorry. 687? Okay. And what does y equal? 600 what? 693. Okay, 693. There we go. Okay. But then from there, is that what the question's asking us? Right? Because it's asking us how wide is the river. And then the river is this right here. It's going to be, because it's saying like this angle of 61 goes to the far bank and the angle of 63 goes to the near bank. And so from there we can just subtract it, right? And so we have the 693 minus 637 equals what? How wide is the river? Yeah. So the river is 56 feet wide. Does that make sense? Everybody see how we got that? Because you have to solve for the two triangles and then subtract it because it's the difference in between the bottom length. We're good? Okay. Okay, and so then we'll go on to the next problem. It says the angle of elevation from a hiker to the top of a mountain is 25 degrees. After the hiker walks 1,000 feet closer to the mountain, the angle of elevation is 28 degrees. How tall is the mountain? And then I'll give y'all another minute or two, like the last one, to draw the picture. Yes. Right? That's okay. Yeah. In a perfectly flat parking lot. Okay, is anybody confident in their drawing? You want to draw it for me? Thank you, Dylan. Nice. Thank you. Perfect. Okay, and so like the problem said, we're trying to find how tall the mountain is, right? So we'll label the height of the mountain as x. But then the one issue that we have is that we only know of this section down here at the bottom to be 1,000 feet. We don't have the whole length of the base of the triangle. So what can we do for that? Right, we can make this part that we don't have of this interior triangle and just label it as z, or label it as anything. And so that way we have a way to like solve for the whole triangle. And so let's draw these two triangles again, but separate, so that we can solve for it and see it just a little easier. So there's a triangle, and there's a triangle. And so we'll say that this is our 28 degrees, and so the triangle with 28 degrees, the base is only z, and so we'll label that as z, and we're trying to find x, and they have the same height of the mountain, and so this angle is 25, and so the 25 degree one is the whole base, right? So this is going to be the z plus 1,000. Does that make sense? Because we're trying to find like the whole base, so that way we can find the opposite side. Okay, and so, oh, that's a tiny triangle. How am I going to set that up in a trig function? Because obviously I'm going to have two different trig functions like before with the previous problem. But how am I going to set it up? Can somebody walk me through it? It is going to be x, but it's going to be x over z plus 1,000. Is that what you said? Okay. Because the whole base is the z plus 1,000. Because the 1,000 feet is just this portion of the triangle. Because that's the only portion that he walks, but we want the whole base. Okay. And so then the other triangle's the exact same with the tangent. So we'll have the tangent of 28 equals x over z, though, because it doesn't include that 1,000 feet. Does that make sense? Okay. And so what do we need to do from there? Because we have two different variables, right? And we can't solve for variables when we have two different ones. And so we need to solve for it somehow. So what should I do? What should we do? Yeah. Yeah, because we're going to solve for the x on both of them and then include it. Great. And so with this one, we'll start with the tan of 28 right here. We have z of tan 28 equals x. And then with this one on the top, we have, I'll write it under, that the tangent of 25. And then we have the parentheses because we're multiplying it by the z plus 1,000, so we have the whole thing of z plus 1,000 equals x. And so because of that, we can set it equal to each other, right? Because they're both equal to x, so they're equal to the same thing, which means therefore that they are equal to each other. And so then writing that out, we have the z times the tangent of 28 equals the tangent of 25 times z plus 1,000. Does that make sense how we got there? Okay. And so from here, we're just going to isolate the z, so we'll just do some algebra to get there. And so we have z.
Jack, did you have a question?
What's your question? Are you sure? Okay.
Let's elaborate. What property allowed us to do this?
Yeah.
General property of A equals B and B equals C, then A equals C. It starts with C as well. Transitive property, yes.
Nice.
So here they're both equal to X, which is why I was just able to set those two tangent expressions equal to each other. The first equals X and the second equals X, so they have to equal one another. Zach said. Help clear it up a little more. Does that help clear it up?
Okay. Awesome. And so then we have the z times tangent of 28 equals, and we're just going to distribute this tangent 25 across. So it's a tangent of 25 times z, but it's not included in the tangent. And then that is the tangent of 25 times 1,000. And then from there, we're going to get the z's on the same side because we're solving for it. So that has the z times the tangent of 28 minus the z. I'm just going to move the z over so that it looks like this one. The tangent of 25 equals 1,000 times the tangent of, or 1,000 tangent 25. And so we know that we have z in both of those, so we can factor it out, right? And so we can factor out the z from both of them of tan 28 minus tan 25. I don't know why it's red, but that's okay. And then we have equals 1,000 tangent 25 because we didn't do anything over there. And then so we'll divide the tangent 28 minus tangent 25 to the other side, so that way z can finally be by itself. And so 1,000 tangent 25 all over tangent 28 minus tangent 25. Okay. That part makes sense, right? We're just getting the z by itself. Just isolate it. Okay, and so let's plug it into our calculator. And then control divide gives us a fraction of 1,000 tangent. What was in the tangent on top? 25. Okay, and then the bottom was tangent 28. Not divided. Nope. Minus tangent 25. Okay. That gives us 7,129.89. Is that everybody else got? 12989. Okay. So z equals 712989? 29.89, right? Right? Okay. And so that is the feet on the bottom. But just like the previous problem, is this what the problem's asking for? Fortunately not. And so we can go up and then write down here and say that z equals 7129, or say 712,989 feet, 219 feet. And then how are we going to solve for x? Because we're looking for the height of the mountain. So what can I do to find x? Multiply what by the tangent of 28? Yeah. Yeah, yeah. right? That's okay, you got it. Because the tangent of, said it's 28, right? Yeah. The tangent of 28 equals the opposite, which is x over the 7,129.89. And then to get x by itself, we're going to multiply that. So 1, 2, 3, tangent 28 equals x. And so can somebody plug that in and tell me what it is? 3,791 feet equals x. Oh, next. That makes sense, right? And it's like you could have done it with the other triangle, with the angle 25, just add 1,000 to it, but then this way you can just cut out one more step. And so that's nice. So we got it? Okay. Cool. Let's go to the last problem. And so we're solving for the entire triangle. And then this is lowercase f. It just doesn't look like that on the paper. And we're solving for everything. We're solving for that missing angle h, the missing side f, and the missing side h. So what do y'all want to solve for first? Okay, so how am I going to do that? Yeah, right, because all of the angles in a triangle equal up to 180 no matter what. And so that'll give me what? 48.6. 6 equals h. Nice. So 48.6. That's okay. So that makes sense, right? Okay. So what do we want to solve for next? Okay. Side h, how am I going to do that? Yeah. Because we have the sine of 48.6, and then the opposite is going to be that h. And then that's over 28, and so we can multiply that 28 over. 28 sine of 48.6 equals h. And what does h equal? 41. 21. I was like, okay, that makes more sense. 21.0. Nice. 21.0. Okay. And then how am I going to solve for side f? Yeah. Okay, so how am I going to set that up? Walk me through it. Because it's going to be, this is like ABC, so it's a squared plus b squared equals c squared. Yeah, that's okay. So it's going to be minus 21 squared. Because then that's going to equal f squared. Yeah. So then we'll take the square root. And so, what is... Okay, we'll just plug that in. Okay. I don't know how to get to the... Oh, there it is. There's the square root. 28 squared minus 21 squared. And that's going to equal 18.5. Yeah. 18.5 equals f. Right. Does that make sense? And then y'all could have, for that, you could have used any trig function to get there also. Yes. Yeah. Yeah. Okay. Well, yes, because it was 21.0 something something something. So I feel like a tenth off isn't a big deal. So does that make sense? Because you could have used trig functions, you could have used Pythagorean theorem, either one. Okay. Awesome. Cool.
Nobody has any questions? Okay. Looks like we got about, say maybe 9-10 minutes left. If you want to hang on to the calculator for a few more minutes, work on the assignment, if you really need it. One thing I've noticed is people are staying on the homework. While we did go ahead and talk about some inverses today, there are no inverses on the assignment. Like numbers 1 through 4, it is not asking you to find theta. It wants you to find sine of theta, cosine of theta. So just the ratio of the sides is what it's looking for. If you have a question on that, just let me know. All right. Okay. So thank you very much, guys. Good job. Okay.